Hi, this video follows on from the previous video which looked at chemical reactions. We will be looking at covalent bonds. Atoms can react with each other to form compounds. When atoms react, they form chemical bonds, and there are two main types of bonding: ionic bonding and covalent bonding. Covalent bonds are where atoms share electrons with each other. Atoms share electrons with each other so that they completely fill their outer shell with electrons. Compounds with covalent bonds have no free electrons and no ions. This means that they cannot conduct electricity. So the two types of bonding are ionic and covalent. Ionic bonding is whereby one atom gives an electron to another, and because the two atoms have opposite charges, they attract to each other. And the other type of bonding is covalent bonding, and this is where atoms share electrons with each other. So let's have an example of a compound that has covalent bonds. The compound that we're going to use is water, and this has the chemical formula H2O. This means that there are two hydrogen atoms and one oxygen atom. Oxygen has 8 protons, and as elements are neutrally charged, it means that oxygen has 8 electrons. 8 electrons will completely fill the first shell. It will have 2 in the first shell, and then the remaining 6 electrons will be in the second shell. The second electron shell, or the second energy level, can take 8 electrons. Therefore, oxygen is too short of its second electron shell being full. Each of the hydrogen atoms have 1 proton and 1 electron. This electron will be in its first electron shell. Each of the hydrogen atoms are 1 electron short of its outer shell being full. So the oxygen atom wants to gain 2 electrons, and each of the hydrogen atom wants to gain 1 electron. Therefore, all of the atoms can share some of their electrons, and this will result in them having a full outer shell, thus making each of the atoms happier. So oxygen shares 2 electrons, 1 with each hydrogen atom, and each hydrogen atom shares 1 electron with oxygen. Each hydrogen atom actually shares its only electron with oxygen. On the diagram, the hydrogen electrons are the blue circles with the red outer ring, and the oxygen electrons are the red crosses. By sharing electrons, hydrogen now has access to 2 electrons and thus has a full outer shell. Oxygen has access to 2 more electrons, 1 from each of the hydrogen atoms, and this makes a total of 10 electrons. This results in its outer shell being full, whereby there are 2 electrons in its first shell and 8 electrons in its second shell. When looking at chemical reactions, it is important to remember that a compound will have different properties to the properties of each element that it is made up of. The final part of this video will be looking at equations. When chemical reactions occur, no atoms are lost or made during the chemical reaction. You have the same number of each element after the reaction as before the reaction took place. This means that the mass of all the atoms before the reaction is the same as the mass of all the atoms after the reaction. So if we take the compound water, the word equation will be hydrogen plus oxygen equals water. And the balance symbol equation will be 2H plus O equals H2O. When writing out the symbol equation, one needs to make sure that it is balanced. This means that there are the same number of each element before and after the reaction, i.e. there are the same number of each element on each side of the equal sign. The easiest way to make sure that an equation is balanced is to find an element that is currently unbalanced and to start adding numbers in front of the entities so that it balances. So let's have an example of an equation that is currently unbalanced, and then we're going to make it balance together. The equation that we're going to use is iron oxide, and we're going to extract it by reduction using carbon. The word equation for this reaction is iron oxide plus carbon then becomes iron and carbon dioxide. The unbalanced symbol equation becomes Fe2O3 plus C becomes Fe plus CO2. Currently, this chemical formula is unbalanced, and we can see this because there are a different amount of oxygen atoms on each side of the reaction. On the left-hand side, there are 3 atoms of oxygen, but on the right-hand side, there are only 2 atoms of oxygen. To make the equation balanced, we can start adding numbers in front of the entities until it becomes balanced. Let's add a 2 in front of the iron oxide. By having 2 iron oxide compounds, we will get 3 carbon dioxides as a result. However, if we check the number of carbon atoms, we will see that there is only 1 on the left-hand side and there are 3 on the right-hand side. This can be overcome by placing a number 3 in front of carbon. We now have the same number of carbon and oxygen atoms on each side. We need to check the final element type, which is iron. Currently, there are 4 iron atoms on the left and 1 on the right. We can solve this by placing a 4 in front of the iron on the right side. This results in our equation becoming 2Fe2O3 plus 3C becomes 4Fe plus 3CO2. A good strategy is to do a final check of all the different elements. And if we do this, we will see that there are 4 iron atoms on both sides, 6 oxygen atoms on both sides, and 3 carbon atoms on both sides. For more videos, content, quizzes, and past papers, go on to www.elevise.co.uk.